Section 7.3 is multivariable linear systems, which really means they're inserting x, y, and z, although they could do w, x, y, and z. Okay, for example 1, I'm more interested in the directions. So it says use back substitution in row echelon form, and then they want you to solve it. Okay, when they say back substitution, they just want you to plug it in. Plug it in. Okay, when they say row echelon form, they're referring to this kind of 3-2-1 pattern. When we get to matrices, we'll actually use row echelon form. For now, I'm not too worried about it. And the 3-2-1 would be like right here, there's 3 variables. This is 2 variables. This goes down to 1 variable, and it makes that nice little step pattern, which we'll use more in another chapter. Okay, so for now, I'm basically just going to go backwards and plug it in to each previous step. So the first thing they tell me is that z equals 5. So I'm going to go to the second equation. I go up to this previous equation, and I plug in z equals 5. 2y plus 5 equals 7. Y equals 1. Okay, now that I got y equals 1, back substitution means now I go back up to the first equation and plug in y and z. And then in this case, my answer is an ordered triple. So x, y, z, 2, 1, 5. Okay, and because it was in row echelon form, it made it very easy to do back substitution. So that's why they talk about row echelon form a lot. And because they want to get you familiar with it for the next, not the next chapter, whatever chapter the major C chapter is. Okay, example 2, we're going to solve this one as well. They often say use Gaussian elimination. As long as you're using elimination, I'm not going to worry about the Gaussian part. Okay, this is a 3 variable system. You remember how fun these are, probably from Algebra 2. Okay, I'm going to label my equations as A, B, C, just because when I'm referring to them, it's hard for you at home to keep track of what I'm talking about. Okay, so I'm going to use elimination. It doesn't matter which variable I eliminate first, but sometimes if I see one that looks easy to cancel, I'm going to go ahead and eliminate that one first. So let's see. I think I'm going to eliminate these z's first. Okay, so I'm going to rewrite these equations. I'm going to put them down here, and I'm going to label them as A and B. So I'm going to rewrite A and B. Okay, let me go ahead and eliminate my z. So if I go down, now I get 3x minus 2y. The z's cancel, equals 10. So now I have an equation with x and y in it. Now I need to produce another equation with only x and y in it. Since I have not used equation C yet, this time I have to use equation C. Okay, so if I look at equation C, I want to cancel their negative 2z's. Okay, I can use equation A or equation B to cancel the 2z's. I think I'm going to use equation B because I can multiply equation B by 2 to cancel out the z's. Okay, so I'm going to make a note. What am I doing? I'm going to multiply equation B by 2, and then I'm going to write equation C. So if I multiply equation B by 2, I get 2x minus 6y plus 2z equals 8. Then I'm going to copy equation C, and then I should be able to cancel my z's. So 5x minus 22y, the z's cancel, equals negative 2. equals, actually that's positive 1, huh? Y equals 1. So I have x equals 4, y equals 1. I just need to go back and get z. Okay, I'm going to get z by plugging back into one of the original equations, a, b, or c. It doesn't matter which one. I'm going to use b, I think, it just because the numbers look a teeny bit easier. Okay, so if I use equation b, x is 4. So x minus 3y plus z equals 4. 4 minus 3 is 1. Okay, so what do I get? I get z is 3. So my answer is the ordered triple 4, 1, 3. If I wanted to check my answer, I could plug in the 4, 1, and 3 into each of the original equations to make sure it equals what it's supposed to equal to. Okay, I'm going to solve, for example, 3. I'm also going to solve it. I'm going to use elimination. Okay, I am going to label my equations, and I'm just doing that because so that when I refer to them, you know which one I'm talking about. Okay, so I need to eliminate a, b, x, y, or z, and I don't see one that is very obviously going to cancel to me. I think I'm actually going to do the x's first. Maybe I'll use equation a and c first. It doesn't matter which pair you use first. I think I'm going to keep a the same. X minus 3y plus z equals 1. Make sure your z's don't turn into 2's, by the way. Okay, I'm going to multiply the c equation by -1. So I can cancel the x's out. So negative x minus 2y plus 3z equals positive 1. Okay, so the x's do cancel. Negative 5y plus 4z equals 2. Okay, now I have an equation with y and z in it. So I need to produce another equation with y and z in it. I used equations a and c for this. I have to use equation b next time. Otherwise, I create this weird dependent system. Okay, so I'm going to look at equation b. This is b. It has a 2x because I want to cancel the x's again. I could use a or c to cancel those. So I'm just going to go ahead and write b again. 2x. Okay, which equation? I'm going to go ahead and use angle equation A, I think. If I want to cancel the x's out, then I'm going to multiply equation A by -2. So equation A by -2. It'll give me -2x, positive 6y minus 2. Okay, what was I? I was trying to cancel the x's. So 5y minus 4z equals 0. Okay, now I have two equations that have y and z in it. So I'm going to go ahead and line those two equations up. Okay, let's see. With the y's cancel, the z's cancel. So I actually end up with 0 equals 2, which is a false statement. And because there's a false statement, 0 is not equal to 2, this system actually has no solution. And it doesn't happen often, but it does happen occasionally.